Okay, in this video, we have this problem, which problem of converting from base 8 to base 2. And my main interest in this problem is to show you how to do this fractional part of it, because I've noticed that many people are having issues with the fractional aspect, getting the correct answer at the fractional part of uh, numbers. Okay, so I'm going to show you how to do it. And normally you start by saying 2 times 8. That is a base to the power of 2, because we have just the highest power we have here is 2. This is 0, 1, and 2. So this to the power of 2. So you say plus 6 times 8 to the power of 1 plus 3 times 8 to the power of 0. Then for the fractional part, you have 2 times 8 to the power of negative 1 times plus 4 times 8 to the negative 2. So I'm going to use my method. Okay, I don't want to say 8 raised to the power of 2, which is 64 times 2. Okay, I don't want to go through that process. Okay, I want to, okay, let me just do it for the sake of people who cannot use this, my method. I mean, the other method of changing everything to base 2. Let me use the normal method that most people are familiar with. So 8 to the second power is 64 times 2 is 128. Okay, this is converting it to base 10 and then to base 2. Then 8 to the power of 1 is 8 times 6 is 48, plus 8 to power 0 is 1 times 3 is 3, and then plus 8 to the negative 1 is 1 over 8 times 2 is 2 over 8, plus 8 to the negative 2 is 1 over 64 times 4 is 4 over 64. So if we add up these numbers, we're going to have 176 and then 179. So we're going to have 179, and adding this, we're going to have that should be 20. Okay, that should be 20 over 64. Adding these two fractions should give us 20 over 6, but the LCM is 64. And then 8 in 64 is 8 times 2 is 16. And then the 64 in 64 is 1 times 4 is 4. So we add these two, we're getting 20 over 64. Now the next thing is to convert this whole number part to binary. Then we now convert this fractional part and then add it to it. So converting 179 to binary, we have this. Dividing by 2, 17 divided by 2 is 8, remainder 1. So in 19, you have a 9. Okay, so your remainder here is 1. Then 2 dividing again gives us 4 here and 4 again, and then remainder 1. And 2 dividing will give us 22, remainder 0. 2 dividing will give us 11, remainder 0. 2 dividing will give us 5, remainder 1. 2 dividing will give us 2, remainder 1. And 2 dividing will give us 1, remainder 0. And 2 dividing will give us 0, remainder 1. So for the whole number part, taking our answer upwards, we're going to have that 179 in base 10 is equal to 10110011. So that is the value of 179 base 10 in base 2. Now for the fractional part, that is the part that I want to really explain properly for some people who are finding it difficult. So the fraction here is 20 over 64, which can be simplified. You can simplify this fraction. 20 over 64 can be simplified. Okay, 2 dividing it will give us 10 up here and 32 down here. 2 can still divide again to give us 5 here and 16 down here. So at the end of the day, we have 5 over 16. Now, what you are going to do for me, okay, what I want you to start doing when you have this fraction, or even if you don't reduce them the way I did, okay, maybe you want to just go straight and convert 20 to binary and then fix your answer here at the fractional part. Okay, that is good. If you reduce it, that is still fine. But there's something I want you to learn. Okay, 5 here, we know 5 should be is equal to 0, 1, 0. Okay, 5 is 0, 1, 0 in base 2, because 1 here is 2 raised power of 2 raised power of 2. Okay, and 1 here is 2 raised power of 0, and 2 raised power of 2 is 4, and 2 raised power of 0 is 1, and 4 and 1 is 5. So I know that 5 is this. Now what about 16? 16 is 1, 0, 0, 0, 0, because 16 is 2 to the power of 4. Okay, 16 we know is 2 to the power of 4. So, and this is 2 to the power of 4. This one here is 2 to the power of 4. So I know that 16 in binary is this. Now, for some persons who have been trying this kind of problem and failing it, once they convert this numerator and get something like this, they quickly come to their answer and say like that 179. I hope you can see that 179 point. Sorry, that should be 2. The original number 263. Okay, let me just write it again. 263.24 in base 8 is equal to they will now put down this 1 point. So some persons will just take this numerator and put it right here, 101 in base 2 as the answer, without knowing that the number of decimal places you have should correspond to the denominator. Now we have 4 zeros at the denominator. Normally, you are supposed to, if for instance in decimal that is in base 10, you have something like, let me say 5 over 100, for instance. You know that if you write this thing in decimal, okay, it's going to be 0.05. It's not true. It's 0.05 because you assume that the decimal point is here, and then you move it this way and cancel one of the zeros. Then you're going to move it again, and you're going to have empty space which you fill with a 0. And then you cancel out this one. So what you have now is 0.05, which is something as 0.05. The same thing applies in binary. You assume that the decimal point is here, you move it this way, cancel out this first one, again, the second one, again, the third one, and then you're going to create a space here to remove the fourth one. So what we have is 0.0101. So your true answer is 0.0101. So this is what you have. This is what you're going to fix to this number, 0101. So if you just convert this 5 definitely is 101. But if you fix it like that, you'll be wrong. Okay, you have to take note of the number of zeros you have at the denominator. You have to change the denominator. I earlier I told you to forget about converting this denominator, but I've seen that it's giving problem to some persons. So you have to convert the two of them, move your decimal point properly, fix it properly before you take it and fix it to your answer. Okay, so that is how I want you to be doing it. Okay, so this is what you are supposed to have as the answer. Okay, some persons will write 1011 This is bad. Okay, because we just converted the 5 at the numerator and fixed your answer there, which is wrong. Okay, so from now on, I want you to also convert the denominator, move the decimal point properly, and then fix your answer. And with that, I'm sure you will never fail this conversion again. And as it applies to conversion from base 8 to binary, that is how it applies to any other base, whether converting from base 3, converting from base 4, converting from base 5, any other base. When you get to that, and especially the ones that have fractional part, when you get to that fractional part, this same thing, okay, this same technique applies.